Today our topic is AC generator. An AC generator is a device which converts mechanical energy to electrical energy, and it works on the principle of electromagnetic induction. In the simplest form, an AC generator consists of a rectangular coil which is mounted on a rotor shaft, and this coil is called as armature. This armature is placed in an external uniform magnetic field. It is placed in such a way that the axis of the armature is perpendicular to the direction of magnetic field. By external means, this armature is rotated in the magnetic field. That means, with the help of an external agency, the armature is rotated in the magnetic field. The ends of the coil are connected to external circuit through slip rings and brushes. By the principle of electromagnetic induction, when the coil rotates in a magnetic field, an EMF and hence a current will be induced in it. This induced current will flow through the external circuit through the brush and the slip rings. Here the brush and slip rings, they act as the terminals. Now we will obtain the expression for EMF generated by an AC generator. As we can see, if the coil is placed with its plane perpendicular to the magnetic field, then the area vector and the magnetic field, both of them, they are in the same direction. That means in this orientation, the angle between magnetic field and area vector is equal to 0. At any instant of time, we assume that the area vector makes an angle theta with the direction of magnetic field. That is, theta is the angle between area vector and the direction of magnetic field. If the coil rotates with a uniform angular velocity omega, we can write that theta will be equal to omega into t. That means the angular displacement theta is the product of angular velocity and time. Since the direction of magnetic field remains constant, and as the coil rotates in the magnetic field, the effective area exposed to the magnetic field, it becomes A cos theta, which can be written as A cos omega t. From the equation, it is clear that this effective area, it is a time-dependent function. That means as the time changes, this effective area changes, which means that the flux linked with the coil also changes as the coil rotates in the magnetic field. So, as the coil rotates in the magnetic field, the flux linked with the coil changes. The flux linked with the coil at an instant of time is given by the expression phi b is equal to BA cos theta. Now, substituting theta equal to omega t in the expression for phi b, we have phi b is equal to BA cos omega t. Since the magnetic flux linked with the coil changes, an induced EMF and hence an induced current will be produced in the coil. By Faraday's law of electromagnetic induction, the induced EMF produced is given by epsilon is equal to minus n into d by dt of phi b, where capital letter N stands for the total number of turns in the coil. Here the negative sign stands for the direction of induced EMF. Now substituting for phi b from equation 3, we have epsilon is equal to minus n into d by dt of BA cos omega t. In this expression, the strength of the magnetic field and area of the coil, both are constants. So the expression for epsilon, it becomes epsilon is equal to minus NBA into d by dt of cos omega t. From differential calculus, d by dt of cos omega t, that is equal to minus sin omega t into omega. That means minus omega sin omega t. On substituting this result, we get epsilon to be NBA omega sin omega t. Here we have the very important expression for induced EMF in the AC generator as epsilon equal to NBA omega sin omega t. In this expression, the maximum value of sin omega t is plus or minus 1. So when sin omega t equal to plus or minus 1, the induced EMF will be maximum and that value is NBA omega. And this maximum value is possible at the values of omega t 90 degree and 270 degree. When omega t equal to 90 degree, sin omega t is plus 1, and when omega t equal to 270 degree, sin omega t is negative 1. So induced EMF changes its direction as per the value of omega t, which means that the induced EMF and induced current, it is changing its direction at regular intervals. That is why the current produced in this generator is called as alternating current and the generator is known as AC generator. The induced EMF and hence the induced current is maximum at theta equal to 90 degree and 270 degree because of the fact that at these two positions the change in magnetic flux linked with the coil is maximum. This maximum EMF we represent with epsilon 0 and the expression for induced EMF in the AC generator, it becomes epsilon equal to epsilon 0 sin omega t, where epsilon 0 is NBA omega and omega is 2 pi nu, where nu is the frequency of revolution of the coil in the generator. Hence, the induced EMF becomes epsilon equal to epsilon 0 sin 2 pi nu t. This equation gives the instantaneous value of the EMF in an AC generator. Thus, in an AC generator, both the voltage and current will be varying sinusoidally with respect to time. When the question comes to draw the schematic diagram of an AC generator, this is the diagram which you have to draw, which shows the north and south poles of a bar magnet and the armature coil, slip rings, carbon brushes and also the axle. Now this diagram shows the different orientations of the armature in the magnetic field and the EMF, the magnitude of the EMF at those instances. So as it is given in the diagram, in the stage 1, it's taken that is the coil, the plane of the coil is perpendicular to the magnetic field. That means in that case theta is equal to 0. When theta equal to 0, you can see from the graph given below, that is the EMF is 0. In the second stage, the armature rotates through an angle 90 degree and the plane of the armature is parallel to the magnetic field, means theta is equal to 90 degree and the EMF induced is maximum. And when it rotates through further 90 degree, now the angle, it is the plane of the coil makes an angle 180 degree with the magnetic field, but theta is equal to 0. Again theta is becoming 0, that means induced EMF is 0. Now when it rotates further 90 degree, that means the plane of the coil is parallel to the magnetic field, but theta is equal to 270 degree here and the EMF is maximum in the opposite direction. So current will be flowing in the opposite direction. And finally, when again this plane of the coil is perpendicular to the magnetic field, theta becomes 360 degree and the EMF induced will be equal to 0, and hence current also will be equal to 0. So those different stages are given in this diagram. Now we have a problem in the textbook. Kamla pedals a stationary bicycle. The pedals of bicycle are attached to a 100-turn coil of area 0.1 meter square. The coil rotates at half a revolution per second and it is placed in a uniform magnetic field of 0.01 Tesla perpendicular to the axis of rotation of the coil. What is the maximum voltage generated in the coil? So here it's given that the number of turns is 100. So N is 100, area is 0.1 meter square and B is equal to 0.01 Tesla. And you are asked to find the maximum voltage generated in the coil. So from today's discussion, we know the maximum EMF induced, it is epsilon 0, that is NBA omega. Here omega is the angular velocity or angular frequency and omega equal to 2 pi nu. So to find omega, here we have an information about nu, that is the frequency, that is the coil rotates at half a revolution per second. That means nu is equal to 0.5. So omega equal to 2 pi nu. Substituting everything in the expression, we will get the induced voltage which is maximum as 0.314 volt. Now, there are different types of generators which are being used. In certain generators, the mechanical energy required for the rotation of armature is provided by water falling from a height. Such generators we call as hydroelectric generators. There are certain devices or certain generators in which the steam produced by heating water is used to rotate the generator. Such generators are thermal generators. And instead of coal, which is used to produce heat, if nuclear energy is used to produce the heat and to heat water and to produce steam, such generators we call as nuclear power generators. Okay, and nowadays in most of the generators the coil will be held stationary and the electromagnet will be rotated. That means armature will be stationary and the field magnet will be rotated. So rotor and stator changes. Actually the words rotor and stator we use in the context of generator. Rotor is used to denote the rotating part and stator is used to denote the stationary part. When we discuss the theory, armature is the rotor and field magnet is the stator. But in actual practice, field magnet is the rotor and armature is the stator. Now, one more important point to be noted, the frequency at which the EMF is induced in the AC generator, it is made constant in India and that frequency is 50 Hertz. So that frequency at which AC is produced is the same as the frequency at which the rotor is rotated. So frequency of rotation of the rotor is 50 Hertz in India and that is made uniform throughout the country. So frequency of AC available in India is 50 Hertz. In certain countries like USA, it is 60 Hertz. So frequency may be different in different countries as per their terms and conditions. With that, we wind up today's session. Thank you.